How make search good? That's a question that I have been thinking about on and off for the last couple of years, most recently in the context of how do you help a coding agent find the context that needs to be successful? I'm going to demo some cool stuff about how I've been thinking about that recently, but I want to first start with a little bit of background on search. The platonic ideal of search is that you put in a query and then you get back the document that has the information you need, like very quickly. This is what I set out to build with Ref when I was thinking about indexing documentation. I was like, okay, this is the ideal. You input a query, you get back exactly the piece of information you need. And that's kind of like what you want out of a search system. But in reality, search, you put in a query, you get a bunch of documents back. You have to decide which ones are relevant, which ones to return. It's a lot more messy in reality than the platonic ideal. And so that leads us to building evaluation metrics around recall and precision. Recall being, did we find all the relevant documents? And precision being, of all the documents we chose to return, what fraction were relevant and what fraction were not relevant. And so when I first built Ref, this was the type of evaluation I was doing. Very classic search evaluation. But as things have evolved, as I've seen the Ref MCP server in practice, my thinking has changed a little bit. And that's because agentic search is a little different than classic query to document search. And it's because the agents will often issue multiple searches and they'll refine their search and iterate over time. So when Claude Code is looking at documentation with Ref, the search pattern actually looks a lot more like this, where it will do a search, it'll then go ahead and refine the query. Now it's got some documents, it'll read a couple documents, then they'll be like, okay, I gotta go look up something else, refine the search again, and eventually it's like, okay, I got everything I need, let's start coding. And the reason it does this is because the foundation model companies are training the models to do this. They're building research tasks in, they're training the models to do research like humans would do it, where you do a search and then you refine your search so you can see what you need, and then you sort of iterate and loop, and like this is what makes agentic search so cool and powerful. And it's not exactly the same, because what I had been building and evaluating for was this, the first search for this query, does it get the right documents? Which is a sub-problem, it's relevant here. But really you want to evaluate the system as a whole and have evaluation metrics that match that. And that's where my thinking has changed, is that I think, instead of recall and precision, I think what we care about right now for coding agents is recall and token usage. The reason for this is we still need recall because we need to find the right information. But what matters is like how much of the context window are we using on this research problem before we get to actually coding. The two reasons for that are, one, the obvious one is cost. Tokens cost money. But then the less obvious one that has surfaced more recently is around context rot. As you add more context, the models get dumber. And so you can't just willy-nilly throw stuff in there and assume it will be just as good as it was before. So I've been building out Ref's eval suite around these two metrics. It's still, in practice looks the same. Like the inputs are actually basically the same, where it's a query and some expected URLs, where the URLs are, links to a specific spot on the page that we're trying to find. And the difference now, though, is that instead of just running a query, we're actually running it in the MCP harness, an agent with an MCP server running. Ref provides a search and a read tool. And so we're going to see it do searches and refine and read pages, and then ultimately, decide that it's found everything it needs, stopped. And while doing that, I track the token usage to understand how much of the context window are we eating up here. So I'm just going to not finish this run because it's actually kind of expensive when you're evaluating token usage because you have to use a lot of tokens. But I'll go look at a prior run here just to show what that's kind of looks like. The two metrics are URL match for recall. Did we find the right URL? And then the token usage. For token usage, I wanted a score to 100%. And I chose the baseline of 10,000 tokens. the reason for this is twofold. One, there's another server called Context 7, which is great. It's a free server for getting access to documentation. The way it works is you choose a library and then get the 10K, like 10,000 most relevant tokens of code snippets out of that library's, like whatever they've indexed. And so there's a baseline of like, okay, well, this is one approach. Like, how much better can Ref be than that? But the other reason is around context rot. So there's this paper from the team at Chroma, where you can start to see that around 10K tokens is when we start to see turnover in the quality results. There's a lot going on in this graph, and I'll link it, but the thing I saw in this graph is around 10K is where we start to see turnover in quality of results. And so as much below that as we can be is good. And so this is what Ref's eval looks like now. To look at some examples of the results, you can see for for some cases, like the best cases where we're saving 95% of tokens. So we're just using 439 tokens to find information about Figma's post comment API. We're doing a search, and then we're going to just read the piece of that page that matters. But then on the other end, where we're using a lot of tokens with maybe a more complex query around comparing different N8N nodes and best practices, we're seeing the model do this sort of search, read, search, this like iterative approach to find things while still really using as few tokens as possible. So I'm stoked about this. I think it's really cool. It's really fun and powerful, and I'll do another post about how it actually works. But this is how I evaluate it.